begin our lesson with an opening prayer. May I request Alima to pray for us? Alima, can you pray for us? Okay, Angel, can you pray for us? Angel? Angel, unmute and you pray for us. Hello, Angel?
Let us pray. Loving Father, we thank you so much for this day. We thank you so much for the gift of life. We thank you so much for everyone that is going to attend this lesson. Come and be in the midst of this lesson. Be with us in everything that we're going to discuss. In this mighty name I've prayed. Amen.
Amen. Thank you so much, Angel, for a wonderful prayer. I believe God has heard and is going to answer what you requested him to do. He's a faithful God. For those who have just joined, my name is Daniel ALIRA. I believe there are those who are joining us for the first time. We are discussing waves, and this is our lesson 4. So that means we introduce waves, we pass through transverse wave, longitudinal waves, we saw mechanical waves, electromagnetic waves, we show terms used in waves, and then the calculations. Today, we are going to see reflection of waves. But before we see reflection of waves, can I see by show of hands? You just raise up your hand. Those who attended the last lesson. By show of hands, can I see those who attended the last lesson? Yes, I see Paul. Paul, can you unmute? Paul? Good.
Yes.
Paul, good. Paul, you're in a noisy place. Can I pick another person? Admin, who's admin? I want to see those who attended the last lesson. Raise up your hand. Yes, admin. Okay. Can you tell us briefly what you said in the last lesson? Okay. Thank you so much. Good. Can I hear from Olivia? Olivia?
Yes, sir.
Can you tell us briefly, did you attend the last lesson?
We looked at the different wave equations.
Sorry?
We looked at wave equation.
We looked at wave equation. Good. Well, we said that wave equation. What is the wave equation?
We said that the first wave equation, it is velocity equals to frequency times distance times wavelength.
Okay, good. We said velocity equals to frequency times the what? Times the wavelength. That was good. That's what we saw in the last lesson, plus the calculations involved. Today, we are going to see reflection of wave. I believe you have seen some bit of light in our O-level physics, senior 2 there, senior 1, senior 2. And I believe the word reflection is not something new to us. Before we see reflection of wave, I want somebody to define for us reflection with reference to light. Raise up the hand. Raise up the hand. I will pick you to define for us the term reflection. Yes, Alima.
Reflection is the bouncing back of light rays when they strike an object.
When they strike an object, is it merely an object, or that object must have specific property?
Sorry?
Any object, when light falls on any object, does it get reflected or on a specific object? Okay, good.
Specific.
Yeah, good. That was good definition. Can I hear from Patricia?
Reflection is the sending away of light rays as they strike to understand smooth shining surfaces.
I wanted that word, shiny surfaces. Akimo, Berry. Akimo?
I have the same answer.
We have the same answer.
Yes.
Okay, reflection is the bouncing back of light rays. That is with reference to light, bouncing back of light rays when or as they strike a shiny surface. On the chart, Paul is saying is when when it strikes a shiny surface. Yes, Paul, you're very correct. So that is what we call to be reflection. So waves can also be reflected. Before we start the discussion of reflection, let's see some of the properties of wave. Some of the properties of wave. Who can give properties of waves? Can you suggest for us some of the properties of waves? Yes, raise up the hand. Some of the properties of waves. Yes, Derek.
We have refraction,
Good.
reflection,
Good.
and diffraction.
Very good. Very good. Reflection has given us almost everything, but there is one which is remaining. Anthony Musinguzi, can you give us that one? Anthony?
They are longitudinal in nature.
They are longitudinal in nature. Well tried, Anthony. Good, good, good. Can I hear from Tabitha?
They can be reflected.
They can be reflected. Good. They can be reflected. They can be reflected. See the hand.
Come.
Okay. Who is this admin? Admin, tell me your name so that I rename yourself.
Can you mute yourself?
Admin, who is admin? Admin, who are you? Tell me your name. Unmute and tell me your name. Okay.
Yes.
So, what's your name?
Martin.
Martin.
Yeah.
Okay, let me rename you Martin.
Okay.
Yeah, because I don't want to be calling you admin, okay?
Yeah.
So now you have the name Martin. So Martin,
Yeah.
do you have another property you want to tell us?
Yes. Waves, they are refracted.
It can be refracted.
Yeah.
Good, good, good. When you go on the chart, I see Precious Priscilla. Patience Priscilla says wave can be diffracted. You're very correct, Patience. Samson Rashford says it can undergo interference. Actually, that's the thing I was waiting for. Thank you so much, Rashford. It can undergo interference. Patience Priscilla again says it can be interfered. Very good. Good. Then Priska says it can undergo polarization. Yes, it can undergo polarization, but there are some waves which do not undergo polarization, especially the longitudinal waves. Longitudinal waves can never be polarized. Only those which are what? Which are transverse in nature are the ones which can be polarized. Reflected, refracted, and diffracted, that is Deborah. Deborah, you're very correct. Maria, interference. Maria, you're very correct. It can undergo interference. So let's be careful when you're giving the properties of waves, especially on the part of polarization. Yes, it is true, waves can be polarized, but it is not that waves can undergo polarization. No. You shall realize that, or you're going to realize that sound wave can never get polarized. It is only light waves which can be what? Which can be polarized. So there are some waves which can never get polarized. So we cannot generalize that waves can undergo polarization. That leaves us with only 4 properties. And at least by now, we know those 4 properties. One of which it can undergo reflection. The second one, it can undergo diffraction. The third one, it can undergo refraction. Then lastly, it can undergo what? Interference. Are you with me, class? Hello, class. Are you with me? Yes. Okay, good. So, those are the 4 main properties. Joshua says yes. Flavia says yes. Good. Mpanje Flavia says, Muyinde says yes. Okay, good. Thank you for being with me. Good, good, good. So the 4 main properties are, 1, we are saying the following are the properties of waves. 1, all waves can be reflected. All of them can be reflected. Then 2, all waves can undergo refraction. We know light in light. How do you define refraction in light? Who can tell us? Refraction? Raise up the hand. Yes. Yebosh. Yebosh, can you define for us refraction?
Refraction or reflection?
Refraction. Refraction.
Refraction is the bouncing back of light rays on a rough surface.
Refraction. We are meaning refraction.
Is the bending of light rays.
Bending of light rays. Good. Is it done? Okay, fine. Thank you. Can I hear from Olivia? Olivia and Ronnie.
Yes, sir.
Good. Can you define for us refraction?
This is the bending back of light rays from a rough reflected surface.
Bending back of light rays from a rough reflected surface. Good. Right. Let me hear from Tracy Op. Tracy Op. Tracy Op. Okay, let me hear from Derek.
Refraction is the change of direction of the wave from one medium to another of different intensities.
Derek, your network. Let me hear from Paul. Derek, go and type on the chat. Paul.
This is the change of the direction of a wave as it moves from one media to another.
Very good. It's the bending of light rays or change in the direction of light rays as it moves from one medium to another, but of different optical densities or different refractive index, please. That is what we call refraction. Joshua says, refraction, Joshua says refraction is the bending of light rays. Let me check well. Joshua says refraction is the bending of light rays as light travels from a less dense medium to a more dense medium. Thank you, Joshua. But the reverse is also true. It may be from more dense medium to less dense medium, or from less dense medium to more dense medium. Is that okay, Joshua? Take note of that. It may be from less dense to more dense, or more dense to less dense. Infinix Odd says it's the bending of light they travel from one medium to another. Good. Densities.
I'm just looking at the pictures.
So that's what we call to be refraction. So we are saying all waves can be reflected, waves can undergo refraction. Then the next property is all waves can undergo interference. Then lastly, all waves can undergo diffraction. Who can define for us interference? Interference, you can raise up the hand. Interference. Maria. Your hands is down again. I see you. Maria, what is interference?
This interference is the position of a wave to produce a bigger wave.
Superposition of the wave to produce a bigger wave. I like that definition. Good. Akimo? Akimo, what is interference?
Interference of a wave is when a wave produces a big wave.
Is when a wave produces a big wave. Isaac says refraction is the bending of light rays as it travels from one medium to another. It's okay, Isaac. But we are looking for interference also. Op is saying this is when two waves merge. Good. When two waves merge. Another term which we can use superposition. Is the meeting of two waves, or superposition. Is that clear, class? I see Paul is having a serious hand up. Paul? 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 Okay, let me hear from Muindo. Esther, Muindo.
Do you have another answer?
Yeah, please give me the answer.
Interference, this is when two waves of similar frequency, wavelength, and speed move in the same direction.
And they superpose, okay? Good, thank you. Somebody on the chat says, that is Moses in Guedo. Is the combination of two or more electromagnetic waveforms to form a resultant wave in which the displacement is either reinforced or cancelled. Good, Moses. And then okay, good. This is when two waves with the same frequency wavelength meet. That is Samson Rashford. Good. When waves superpose, that is Priscilla. Very good. All the definitions are correct. But let me give you the definition of interference. Interference is the superposition. Is the meeting of two waves of the same frequency, same amplitude, and same wavelength, resulting into formation of maximum and minimum intensities. Superposition of two waves of the same frequency, same wavelength, same amplitude, resulting into formation of maximum and minimum intensities. Some books or some authors say that it's the superposition of two waves from coherent sources. When I talk of coherent sources are sources of waves. These are two sources which produce waves of the same frequency, same amplitude, and same wavelength. But for us, we are not going to use that term. We are going to say is the superposition of two waves of same amplitude, same wavelength, same frequency, resulting into formation of maximum and minimum intensities. The details about interference we are going to see when we reach there. Then, lastly, is the diffraction. Who can define for us diffraction? Diffraction of a wave. You can raise up your hand. Diffraction of a wave. Yes, Joseph? Joseph?
Diffraction is the spreading of waves around obstacles.
Very good. Spreading of waves around obstacles. There's another person with a better definition, and that is Musinguzi Anthony. Anthony?
Diffraction is the spreading of waves in different directions after passing through a narrow gap.
Spreading
after passing through a gap.
Directions after passing through a narrow gap. Good. You people have matter. Let me hear from Jovia.
The diffraction is the spreading of waves around obstacles as they pass through a gap.
They pass through a gap. Thank you so much, everyone, for the submission. I'm going to pick only one more person, and that is none other than Vanessa. Vanessa? Okay, I'm giving that chance to another person. Let me give that chance to Deborah.
Diffraction is the process by which a wave is spread out as a result of passing through a narrow aperture.
Good. Let's check on the chart. Moses Ingwede says is the spreading of waves as they pass through walls of round corners of an obstacle. That is Priscilla. Not Priscilla, pardon, sir. I'm going to pardon. The spreading of waves around a barrier. Good. Trustee says diffraction is the spreading of waves behind an obstacle, which is correct. So diffraction, we say, is the spreading of waves, as it passes through, spreading of waves as it passes through a narrow aperture or a narrow gap. However, you can also say is the spreading of waves beyond geometrical shadow. I don't want you to confuse the definitions. You can either say is the spreading of waves beyond geometrical shadow or spreading of waves as it passes through a narrow gap or a narrow hole. Good. I see some hands up. Could you be giving another definition or a concern? Can I hear from Joiner? Good. Mubi. Joanna, what do you have to say?
Diffraction is a spreading of waves as they pass through narrow corners beyond the geometrical levels. Diffraction is the spreading of waves as they pass through narrow corners beyond geometrical levels.
Very good. Beyond geometrical levels or beyond geometrical shadow. Good. You've combined all the two definitions. That was good. Then Patricia says, is the spreading waves as they pass through a barrier or a gap? William says, I'm fine and how are you? Please, you are talking to me. Thank you, I'm also fine. So these are the four main properties of a wave. It can be reflected, it can be refracted, it can undergo interference, and it can be diffracted. These are the main properties of a wave. Today, we are going to see the first property. We're going to see the first property, and that is reflection of waves. We have already defined reflection. We said is the bouncing back of light rays as they hit or they strike a shiny surface. So here, when you're talking about wave, we are also using the same definition, but we are not going to use the word light. We are going to use the word wave. So it's the bouncing back of wave as it strikes a shiny surface. Is that okay? Is that fine, everyone? Jesse says, yeah. Martin is having the hands up. Martin, I see your hands up. Martin, yes.
So it's fine.
It's fine.
Yeah.
Good, thank you. You can lower your hand because when you raise it, to me it looks as if you have a question. Okay, good. So by definition, we are saying reflection of wave is the bouncing back of waves when they meet a barrier. Okay? In this case, a barrier acts as the reflecting what? The reflecting surface. Now, there's a bounce down there. There are some NBs down here. The first one is saying that the laws of reflection of waves are similar to the laws of reflection of light. Maybe to remind ourselves, what are the laws of reflection of light? Laws of reflection of light, you can raise up your hand. Yes, Grace. Grace?
Yes. The first law is the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane.
Very good. The incident ray, the reflected ray, and the normal at the point of incident all lie in the same plane. That is a reflection. Then another one. Let me give that chance to Mose. Moses?
The reflected angle is equal to the angle of incidence.
That statement?
The angle of reflected ray is equal to angle of incidence.
Wait, but the angle of incidence is equal to the angle of reflection. Is that okay?
Yeah.
Is it okay, Moses?
Yeah.
Yeah, the angle of incidence is equal to the angle of reflection. Those are the two main laws. Reflection. The two main laws of reflection are those ones. Rachel says change of direction, good. And then Deborah is saying reflection is equal to the refraction. The reflected angles is equal to the angle of incidence, that is William, good. So all the laws apply here. All the two laws will apply here. Then the next thing which you have to note here is that the shape of the reflected wave, you hear that? The shape of the reflected wave depends on the shape of the barrier. Do you hear that statement very well? Moses in what he says, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Please, Moses, this is not the law of reflection, but rather is the law of refraction. Yeah, it's the first law, Snell's law of refraction, that is the second law. Richard, official, what is the problem? I see hands up, Richard. You're taking it down, okay? So the shape of the reflected wave depends on the shape of the barrier. Please be careful. The shape of the reflected wave depends on the shape of the barrier. That is, if the barrier is straight, we shall see very many types of reflector. We shall have a straight reflector. We shall have an inclined reflector. We shall have a curved reflector, that is convex, and then concave reflector. So the way this one will reflect will not be the same as the shape of the reflected wave when it is incident on this. Will not be the same as the shape when it's incident on this. Will not be the same as the shape when it's incident on that. Is that clear, everybody? You can give me a sign or you can tell me in the chat, yeah or no. Is that clear, everyone? Yeah, I see very many yeahs. Good. I have enjoyed this senior theory. It's only God who knows. I've enjoyed this senior theory. There are some people who are saying no. Pardon, sir. Okay, let me pardon it. We are saying that if a wave is incident onto a reflector, which is the barrier, the reflector may be straight, the reflector may be inclined, it may be at a certain angle to the horizontal, the reflector may be curved like this, the reflector may be curved like that. So when you pass wave on this one, the way the reflected wave will be is going to be different from when you pass the same wave on this. It will also be different from when you pass the same wave on this. It will also be different from when you pass the same wave on this one. So that's why you're saying that the shape of the reflected wave depends entirely on the shape of the reflector or the barrier. Is that clear now? Somebody saying, please show us how it is every day. Very. Somebody saying, very clear. Thank you. Very clear. Very clear. Good. Crystal clear. If you are not easy, crystal clear. I don't understand when you say crystal clear. But let me assume that it's just clear. Good. Now, at this point, we are going to discuss, okay? We are going to discuss. Tracy says, we are understanding. Thank you so much, Tracy. That's good. Isaac is very up there, laughing. Good, 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 good. So, when we are dealing with the reflection of wave, we should know that different types of reflectors will produce different what? Different reflection. Let's go to some of the illustrations. We are starting with number 1. A plane reflector. When I talk of a plane reflector, it is just like a plane mirror, like this, straight. A plane reflector. So a plane reflector may be straight and inclined at a certain angle. This is what we call to be a straight plane reflector. This is what we call to be inclined plane reflector. So, how does it reflect other waves? Number 1, part 1. When a straight wave is incident, when a straight wave is incident on a plane reflector, when a straight wave is incident on a plane straight reflector. So that means that if we have straight wave, that means that we also have curved waves. Yes, you're going to see that we have circular waves. So when a straight wave is incident on a straight reflector, what happens? When a straight wave is incident on a straight reflector, a plane wave is reflected back. So if I have a straight wave like this, a straight reflector like this, and then I incident a straight wave on it, when I incident a straight wave on this one, it will reflect a straight wave. It will be reflected back. Is that clear, everyone? Is it clear? Give me a sign. A straight wave on a straight reflector, it will be straight. Good. Somebody says it's good, clear. Good, good, good. Yes, it's clear. JB says it's very clear. Yeah, it's clear. Yeah, it's clear. Cloud. Good. So that is one. When a straight wave is incident on a straight wave, on a straight reflector, a straight wave is reflected back. That is the diagram. So here we have the plane reflector, which is straight, and this one is the incident wave, the straight one. You can see the reflected one is also what? They're also straight, being reflected. That is one. Then number 2. When a straight wave is incident on an inclined plane reflector, this time around the reflector is inclined. So we have a straight incline. So this is a straight incline. Now when an incident horizontal wave like this, when a wave is incident horizontally like this, on this, the wave which is going to be reflected will be the vertical one. It will turn to be the vertical wave. The vertical wave will be reflected. Now, if I incident a vertical wave onto this, horizontal wave will be reflected. So you have to note that for when the plane wave is, when the plane reflector is inclined, then when you incident a horizontal wave, it will produce a vertical wave. And when you incident a vertical wave, it will produce a horizontal wave. Is that okay, everyone? Give me a sign. If you have any question, you can raise up the hand and you ask. Yes, Joseph?
I beg your pardon.
Good. We are saying if we have the plane reflector which is inclined, the plane reflector inclined, and you incident a horizontal wave, it will produce a vertical what? A vertical wave. Is that okay? Is that fine? And if I incident a vertical wave, it will produce a horizontal what? A horizontal wave. Is that okay, Joseph, now? Good. He says, yeah. MK, is it okay now? Akimo, is it okay now?
No.
What is not clear? Akimo?
I have not got that explaining.
Let me draw the diagram and then maybe possibly we'll see from there. Is that okay?
Yes.
Good.
Excuse me, sir.
Yes. Please, can you go on? This is the diagram. We have horizontal. I see in this plane, it is inclined at an angle. Do you see that? So we have horizontal wave being incident. These are horizontal what? Horizontal waves are being incident. You see the reflected wave have turned to be the vertical what? The vertical wave. This is what I've been talking about. Have you seen it?
Yes.
You have seen now Akimo, okay?
Yes.
Is it clear now?
Yes.
Now you see the horizontal. This is the vertical wave. Have you seen the vertical wave for this one?
Yes.
Vertical wave have turned to be what? Horizontal. Is that okay? So let me have that is very fine. Good. So that is when it comes to plane reflector. Okay. Then let's go to part 3. When a circular wave is incident on the straight plane reflector. So that one becomes very simple. When I have a plane reflector like this, and I incident a circular wave, do you see that?
Yes.
I hope you can see this one, okay? The reflector will just turn it back like this. Is that okay?
Yes.
After reaching the reflector, it will just turn back like that. Is that clear anyway? Okay. So we are saying when a circular wave is incident on a straight plane reflector, comma, the reflected wave is circular. So it will just be this. So this is the incident wave. I see the incident wave. It is this one, this one. It's from here to here. It's going towards the reflector. Then when it reaches the reflector, what the reflector will do, it will just turn this one back. It will just turn it back to where it is coming from. Good. Kemigisha, Brittany, I see your hands up.
Master, I would like to know what's the laws of a plane reflector.
You want to know the?
Excuse me, sir.
You want to know what? Okay, Deborah?
Yes, sir. I was asking if the direction matters when you're reflecting a circular wave.
The direction?
Yes.
Yeah, even if you draw like this, do you see what I'm drawing?
Yes, please.
If you draw like this, if it was coming like this, okay, this one will just turn it like that. Do you see that? Have you seen it? Let's say it was like this. This is the incident wave, okay? Then the reflected wave would just turn like this. This plane reflector just reverses its direction. Okay. Good. Let's move to something else. So that is for plane reflector. Then let's go for concave reflector. Concave reflector, you know a concave mirror. A concave reflector is like this. This is a concave reflector. So, when I incident a straight wave on a concave reflector, I expect it to take the shape of the concave. Good. So let's see part one. Part one, a straight wave incident on a concave reflector. At least at this point, we know what a straight wave is. So we're saying that when a straight wave is incident on a concave reflector, the reflected wave is concave. Please take note. When a straight wave is incident, a straight wave is incident on a concave reflector, then the reflected wave is also concave. In other words, the wave is forced to take the shape of the reflector. So if it is a straight wave incident on a concave reflector, the reflected wave is forced to take the shape of the what? Of the reflector. Is that clear, everyone?
Yes.
Good. So this is the diagram. Then part two. When a circular waves, a circular waves on a concave reflector. Now we are saying when a circular wave is incident on a concave reflector. It will make it straight. Remember, we had a straight wave being circular, but now a circular wave will be straight. Did we get that?
No, pardon.
We saw a straight wave incident on a concave reflector, okay? We found that the reflected wave was straight, was circular wave, no so? When a straight wave is incident on a concave reflector, a concave wave is produced. But when we have a concave reflector and we have incident a concave wave, then a straight reflected wave will be produced. Do you get that? You can give me a signal. Yeah, it's okay. Yeah, it's okay. Somebody saying, yeah, it's okay. Fine. In case it's not okay, you can raise up the hand and then you let me know. Yes, Joyce. Joyce?
Yes, Mister.
Yes, please.
Good morning.
Good morning. How are you?
I'm fine. I wanted you to show me the points of incident on example number 2.
On example number 2?
Yes, where you told us that when a straight line is reflected, it gives what? An incident line which is horizontal.
Oh, that was very far.
We wanted you to repeat on that, all of us.
So you see, I guess this is what we are talking about.
Yes, sir.
So this is the incident wave, okay? Yeah, it is incident wave up to here. So we are saying that if it's horizontal, this one will be reflected vertically.
Okay.
Yeah, if it's horizontal, it will be reflected vertically. If it's horizontal, it will be reflected vertically. Then when it comes to this, if it's vertical, okay, it will be reflected horizontally. Is that okay? Vertical, horizontally.
Yes.
Is that okay? Yeah, that's what we are talking about. Is it clear now?
Yes.
Can I go?
Yes, I've seen the point of incident.
Good, thank you. So we are saying that when you have a circular wave incident, when you have a circular wave incidence on good. Then let's go to almost the last one. Convex reflector. When talk of convex reflector, a convex reflector is like this. This is a convex reflector. So when you incident a straight wave on a convex reflector, it will be forced to take the shape. So we expect also something like this. It will be forced to take the shape of the reflector, as we are to see. So we are saying when a plane wave is incident on a convex reflector. When a plane wave is incident on a convex reflector, a convex wave is produced. I already told you that. When a plane wave is incident on any curved reflector, it will be forced to take the shape of that reflector. We saw a plane wave on a concave reflector. It was forced to take the shape of the what? Of the concave reflector. And here is the plane wave. Plane wave incident on a convex reflector. And it is taking the shape of the what? Shape of the reflector. Is that clear, everyone? Please let me know. Yes, Grace says yes, it's very clear. Good. Yeah, man. Yes, yes, yes. Yo, yo. Somebody saying yo. Okay. So this is for plane reflector. I mean, a plane wave on a convex reflector. Then convex reflector still, circular wave on a convex reflector. Good. I see some hands up. Let me take Tendo. Tendo?
Sir, I was just requesting you to continue.
Okay. Akimo?
Yeah.
Akimo?
Sorry, the hand is just up.
Okay. Kali, thank you. So, we're saying circular waves on a convex reflector. When we talk of circular wave on a convex reflector, we are saying that when a circular wave is incident on a convex reflector, the reflected wave is convex. You see, convex is resistant. Anything you incident on it, it will make it take the shape of itself. We have seen plane wave incident on convex, a convex wave is produced. Circular wave incident on a convex wave is still what? Still produced. So that is the behavior of a convex. Actual reflection of convex is very simple because anything you incident on it, it will take the shape of that reflector. Good. I see Alvin is having the hands up. Alvin?
Excuse me, sir.
Yes?
Sir, like I came late for the lesson. Where can I get the notes? Because my network was not good.
I will put the notes on Google Classroom. That is 1. 2. I'm going to put it on WhatsApp group. Are you on WhatsApp?
Yes, I sent the number for the WhatsApp.
Yeah, I'll put it there. Or you can even inbox me and send to you directly. Is that okay?
Okay, sir. Can you get me your number?
Okay, I'll get it for you at the end of the lesson. Just be ready, okay? So have we got this point? Have we got this point? I see Philomena is having hands up. Philomena?
Thank you.
Teacher, I just wanted to tell you that last week's work was not done on Google Classroom.
Surely, go and check well because I posted them there.
Okay,
Even with
teacher.
Okay, good. Brian, Joseph, Brian.
Yes, teacher, where can I find the work after the lesson?
On WhatsApp and Google Classroom. I'll put them right away from the lesson. Good, thank you. So this is the point, and I see some comments here. This is, I saw. Can I get the WhatsApp number? Yes, you can. So this is the circular wave is then on a convex reflector. Circular wave on a convex reflector is convex, as simple as that. Good. Thank you so much for being part of this lesson. I'm glad to inform you that next week, in this time, we shall have a test. Is that okay? We're going to do our examination. So be ready. And I will set only from within what we have covered. Is that okay, everyone? I'll set only from within what we have covered. So next week, get ready for the test. Those who want the WhatsApp number, you can write it down. It is 070
Some of us are dead.
It is 070 375 0387 070 375 0387. Is that one on the screen? Is that one? Yes, Mr. Bernard, thank you so much for sharing the screen. Thank you. It is 070 375 0387. Please, we have the test next week on Friday at this time. Get prepared for the test. Thank you for attending the lesson. Let me call upon my super admin to say a word as we leave the class. Yes, Mr. Bernard?
Yes, thank you, Teacher Daniel, for taking us through this lesson. It was really massive, and I'm sure the learners enjoyed it. So go prepare in all subjects that you have been studying online for a test, which will be on next week. So next week you shall have tests. The other week, teachers will mark and then they will turn your results. The rest of the communication will be passed on. Have a great weekend.
Goodbye, everyone. Goodbye.
Actually, we have English at 2 p.m. Don't miss English. Inform your colleagues. Bye-bye.